Engineer Shekhar Jeurkar. We are lucky that he's with us second time. The inaugural session has been engaged by Sir, and now the last day, second session, Sir is with us. So good afternoon once again, all of you, and welcome to Professor Shekhar Jeurkar. And as a formality of the program, I would like to introduce Sir in front of all the participants. So, Engineer Shekhar Apparao Jeurkar, an accomplished academician and professional with a wonderful combination of industrial, teaching, and consultancy experience. Professor Jeurkar holds a B in metallurgy from Government College of Engineering, Pune, a DBM from Bharati Vidyapit Institute of Management, Kolhapur, and ME in Mechanical Production Engineering from Walchand College of Engineering, Sangli. He has also completed a diploma in non-destructive testing from Government College of Engineering, Pune. Professor Jeurkar has commendable 6 years of industrial experience with reputed companies like KSB Pumps Limited, Pune, and Shivaji Works Limited, Solapur. He transitioned into academia with an impressive 30 years of teaching experience, including 21 years at WIT Solapur, 4 years at NK Orchid Solapur, and 5 years at BMIT Solapur. A dynamic entrepreneur, Professor Jeurkar also heads his own firm, SAJ Consultancy Services, providing specialized solution in heat treatments, foundry defect analysis, and microstructure analysis of metals and alloys. Professor Jeurkar's contribution to the field include 3 patents such as low-cost bio-waste fuel briquettes, cervical spine expandable cage, and infrared melting furnace. He is a certified ASNT level 2 professional in liquid penetrant testing and an active member of prestigious professional bodies like the Institute of Engineers, Indian Institute of Metals, and Indian Society for Technical Education. As a consultant, Professor Jeurkar has worked with leading organizations including Solcast Precisions Limited, Maruti Products Limited, and the Indian Meteorological Department, Pune. His areas of expertise span heat treatments, NDT, foundry defects analysis, and material selection. We are privileged to have Professor Jeurkar with us today, sharing his wealth of knowledge and insights. Let us extend him a warm welcome, and I request Sir to start his session.
Yes, sir. Thank you. Shall I start now?
Yes, sir.
Okay.
Please share the PPT, sir.
Yes, is it visible?
Yes, sir. Yes, sir.
Okay.
Okay, sir. You can start.
Okay. Good afternoon to everybody.
Good
I'm
afternoon.
very much thankful to the trustee management, then the principal, vice principal, dean, all head of department, coordinator of this particular function, and the course. Then I'm also thankful for the all other people who are behind the screen, the network people who are responsible for this very wonderful presentation, and the dear participant. So a very warm good afternoon to everybody. Now, if you remember that I have already taken one particular lecture on advanced material, specifically classifying the composite materials. Now the next part, which is in front of you, is the title Smart Materials. And I am taking the privilege of continuing my lecture from the previous topic, that I am continuing with the medical application. At some stages, you will find the other applications also. but I am trying to concentrate on medical application because this particular field is slightly an oversighted field by engineers. And I always advise that the materials engineering is such a vast subject that you should concentrate on materials engineering irrespective of your field, because this is interdisciplinary type of field. Now, before starting my lecture, now let me first explain why we are supposed to study this particular topic, smart materials. Now, the title itself, smart, indicate that the materials are smart. Means what? Now, till now, what we say that the materials are the materials which are in the static form. That means once you have manufactured it, they are as per their properties, which we have studied in our physics, chemistry, biology, and so on. That means in our school and college days, what we have studied, there were different chapters like heat, light, then electricity, magnetism, then the thermal properties, and so on. That means there were chapters according to this, that is heat, light, and so on. Now, in the last 70 years, people have found out that not only human being or the livestock, but the materials are also responsive. That means if you apply certain form of stimuli to materials, they will respond to your input. So materials which gives you certain responses to your input are generally called as smart materials. So the title itself is very typical. Smart materials means the materials which can give you the certain information in the form of certain energy conversion, in the form of certain parameter conversion, or in the form of certain changes in the dimension, shapes, and so on. So this is the first part which I am trying to tell you. Now the second part is very important, which I have already mentioned in the previous lecture also, that nowadays our lifestyle is totally changing and we are becoming very conscious about our health. We are very much responsive for our health, and any small thing which happen to our health, we immediately go to the concerned doctor or say hospital or try to get the proper treatment and so on. Now, as the response to the diseases from a human being is very quick, naturally the second part comes that the response from the other side, that means doctors, then medicines, then the hospital should be very quick. And it is our expectation that if I go to a doctor immediately within certain period of time, I should get cured, because our lifestyle is so fast that we cannot waste time. That's why lot many innovations is done in the field of medical sciences, along with, now please remember, along with is very important, along with materials engineering, second electronics, third as the data acquisition system, then generation of information through the computers, then internet of things, and so on. So nowadays we are having combination of all these things with medical application. In the previous days this was not possible. It was the holistic approach of the doctor, that he understood what is in front of him, then according to his information, knowledge, then previous experience, he diagnosed the things physically. That means in the previous days you must have seen that the doctors with the help of stethoscope go on finding what are the things with our heart, with our chest, with our back, and so on. Then he put one tongue depressor in our mouth, go on finding out the details. Then he asks us to open your eyes, then close your eyes. He just check with the help of hammer your bones in your legs and so on. But nowadays you will find that it is not like that. Doctor is sitting on one side, table is in between patient and doctor. He go on asking you question and he go on writing down something, and immediately he asks you to get certain test carried out, and from the test, information of the test, he decides what should be the course of action for your disease cure. So now the totally technology is changing, because now the blood testing with a standardized material is same if you go anywhere. A ultrasonic sonography for a typical machine is same if you go anywhere. Means what? Now it is the standardization. So test standardization are naturally requiring the materials which are extremely responsible for the test. So the smart materials are nowadays very much required. Okay, with this preamble, now I'll go to the slides. Okay, now the first part. Now this is a very typical picture. A person carrying a backpack on his backside, and he is having certain things in our hand. Now generally you'll find that a phone or a mobile is always with us and we are like this. But what is the future? Now you can see the future. Now see here, he is having certain hearing aids. Now these hearing aids are not only for him, but it is giving you the details which is received from the data acquisition system. Then there is a sweat based sensor which is on the top here. That particular person, if he is walking, if he is having certain problem, the output is sweat. The sweat sensor give you certain information. It is collected through a certain sensory system. Then if you come on this side, then there is a smart pacemaker. Now this pacemaker check what is the work done by this particular person. If required, this smart pacemaker will give him the signal that okay, now you are tired, take certain rest, take certain input, food input, and then continue with this one. Then you will find that here on his hand you can see two important points, out of which one we have already started using, that is a smartwatch. On the back side you will find that there is a skin. It is called as the electronic skin. Now this electronic skin senses number of inputs from your body, and that data is collected. The smartwatch which we are using for checking our BP, then the pedometer where we have, if you are getting a morning walk, how much distance you have traveled. There in COVID you must have seen that what is the oxygen level, then your blood pressure, everything is monitored here. Then you will find that all these details, you'll find that the input or the power source is solar energy. So the solar power rechargeable system will go on continuing with this particular system. Also this scheme will be smartwatch for health monitoring, artificial intelligence, then machine learning, Internet of Things will go on collecting the information. Then this artificial electronic skin will give you, if required, certain corrections. That means this particular system, if it get worn out, then it will give that particular signal, and immediately with the help of 3D printing, the next set is obtained. Now this electronic skin will be different from each and every people. So that will collect a lot of information. Now you can see here there is a microneedle patch for drug delivery. Suppose this particular person is having diabetes. So you'll find that there is a small equipment which is having a small needle. As the blood pressure increases, there is a small prick of insulin which is put in his body, and he will immediately cover whatever is the high sugar level. So this is microneedle patch. Then on his leg there will be certain sensors which are triboelectric and piezoelectric based sensor. Now this will tell what is the distance, what is the condition of his knee, whether he has overwork, whether some problem is there. He may use this particular continuously, or he may put it after 3 months, 6 months, and so on. And as a result of what is the degeneration of its bones can be understood. So this is one of the part. In short, this will be the future. So a person will be supplied with medical gadgets. Now till we are using the entertainment gadgets, but the person will be fitted with medical gadgets. Now these medical gadgets will go on collecting the information through artificial intelligence. It will be centralized. Now you must have seen that for elderly people, Government of India has already given ABHA card, and in this ABHA card, it is the convenience, and there is one particular facility that all the reports of a person can be stored, and that can be made available anywhere throughout the India whenever you require. You put your number, you will find that whatever is your history of diseases is available to any doctor, whether you are in your hometown or anywhere else. The doctor can get this particular information. So this is the future of our medical system. These are generally the medical gadgets. Okay. Now our title of our course was advanced material. So where the smart materials falls. Now the smart materials, if this is the classification, you will find that advanced materials are of 4 types: nanomaterials, smart materials, then hybrid materials, and electronic materials. So advanced materials are generally classified with these 4 different types of systems, and that particular system is further classified with the help of information as well as different branches. Advanced alloys, which are intermetallic shape memory alloys, advanced polymers, electroactive self-repairing materials, then biopolymers, DNA-based, sugar-based, lipid-based materials. Then there may be porous materials, microporous. Now these microporous will be less than 2 nanometer. Then mesoporous, this will be in between 2 to 50 nanometer. And macroporous will be greater than 50 nanometer. Now there will be particulate system, quantum dots. Now these are the tiny semiconductor particles which are required in optoelectronics. Then nanoflowers. Now nano-size flowers shaping with very high surface area to volume ratio, which are greater than the sphere. That means this is a very typical property of nanoflower. And graphene, as you must be knowing, these are the nano-size extract of graphite or pure carbon, very hard, which is hardness greater than diamond. So this is graphene. Then we are having advanced fibers, silica, carbon nanotubes, then composites, hybrid materials, macroscopy, and metamaterials. Now this is a very important group of materials nowadays. Now these are the synthetic materials which interact with electromagnetic radiations, that is electromagnetic radiation, then sound and mechanical forces. So metamaterials are also gaining a lot of importance nowadays. In short, this is the title advanced material. So advanced material consists of all these types of materials which are used in number of fields, interdisciplinary, including engineering, sciences, then automobile industry, medical, and so on. Okay, so this is one part. Okay, now the important point, what is smart material? A smart material is having certain working principle. Now, what are these working principles? According to the working principle, the smart materials are classified or they are given certain names. A piezoelectric material is a material to whom, if the input is stress or electric field, now this material will generate an output that is electric charge or mechanical strength. Now this is the characteristic of piezoelectric material. Second is electro-rheological fluid. The input is electric field. Now from this, you will find that the material changes its viscosity, which is generally used in shock absorbers, internal damping. Now this is called as electro-rheological fluid. Third group is called as magnetostrictive material. If you give magnetic field as the input, you'll find that the mechanical strain is output. That means it gives you certain change in dimension, then it will change the shape and so on. Then the shape memory alloys, we already studied this. If heat is the input, you'll find that the original memorized shape can be regained. So these materials remember their original shape. That's why they are called as shape memory alloys. And the last group of material is optical fibers, where the input is temperature, pressure, mechanical strain. The output will be change in optoelectronic signal. Now this is generally used in telecommunication system, communication line, and the communication which is done with the help of satellites. Okay, so these are called as the working principles of smart materials. Okay, now there is a slight repetition, but I will repeat that particular part so that you can understand what group of material is required here. So the left hand side remains same. Now type of smart material, this chart is extremely important because this right hand side column will give you which are the materials which are having these smart characteristics. Okay, type of smart material is piezoelectric. Input is deformation, output is potential difference. Now these are the materials, that is quartz, then Rochelle salt, topaz, bismuth, and ferrite. Now these materials can change the characteristic. That means if you apply certain force or load, they will give you potential difference. That means electrical output. Then electrostrictive type of material, if you apply potential difference, then they will deform. That means there is a mechanical observable change in shape. There is mechanical observable change in strain and so on. So lead, lanthanum, zirconate, titanate, that is PLZT. Now this P is not L, it is similar to L. P stands for plumbum. Lead is Latin language, it is called as plumbum. So it is PLZT. Then lead, magnesium, niobate, PMN. Then there is a magnetostrictive where the magnetic field is the input, output is again deformation, cobalt and terphenol D. Now I'll explain what is terphenol D later on. Then thermoelectric material, input is the temperature, output is the potential difference. So beta Zn4Sb3 alloys, then chalco genides, then CS Bi4Te6. This is an alloy of carbon, bismuth, and tellurium. Then shape memory alloy, input is temperature, output is deformation. This is a very common material. Copper, aluminum, nickel, iron, manganese, silicon, copper, zinc, aluminum, and nickel, titanium, nitinol, generally, which is very famous. Okay, next group is very important, photochromic. Now, if the input on this particular material is radiation, they will change their color. V2O5, then cholesterol, nanonet, then 1,2,3 triazole, octa, decyl, phosphoric acid. Now, this is very famous in, you'll find that if anybody is from heat thermal side or metallurgy side, he will understand that generally in foundries, these materials are used. They are called as the Shekhar cones. It is earthen material which is kept in a furnace. And when the temperature is reached, suppose you want to check, you have to just get the information about 800 degrees centigrade. At 800 degrees centigrade, that white color cone changes its color. So it gives you that, okay, the furnace has reached 800 degrees temperature. So these are photochromic. Then second one is thermochromic. If the temperature is given as the input, then it will change the color change. These are azobenzene, then diethylene spiropyran, then silver chloride. Then there is electrochromic. If the input is electric voltage, the output is color change. It is WO3, NiO3, TiO2, then polyaniline and polythiophene. Now, all these things you will find here, these are the oxides. Now, what is the importance of this? Now, see, this particular chart is extremely important for the selection of material. In any medical system, now I'm trying to concentrate on medical system. Now, there is certain signal. I'm taking the example of a disease. There is certain signal which a body gives. Now, this signal has to be sensed first. Then it has to be understood. That is the second stage. Then third, there must be a decision-making stage. Then the fourth will be selection of a drug. And the fifth one will be administration of the drug. Now, these are the different stages. At different stages, generally, what happens, now here you will find why such materials or these materials are required nowadays in medical sciences. Now, see, in the older days, our food habits were okay. The synthetic food was consumed very less. So naturally, the chances of diseases were very less. Second point, the person were having body work. That means there were no automobiles or say bicycles and so on, primitive stages automobiles. So people were having naturally in their day-to-day work a lot of exercise. So the consumption of a food, then because of the exercise, digestion of the food was very simple. It was very convenient. But nowadays you find that this is very difficult. It is because of the synthetic foods. Now these synthetic foods have generated a lot of diseases with the help of bad practices in our day-to-day life. So the exercises of a common human person exercises very, very less. So these particular things have generated the need of different medicines. Now see, the problem is medicine. I will just give you one particular cycle. Everybody of us has gone through this cycle. Suppose I am ill, I have gone the fever. So I go to the doctor. Doctor says, okay, you are having a flu or a typhoid or whatever may be. Now you take these 5 different varieties of tablets. So he gives you a very big prescription. You go to the chemist, you bring all these things. You start consuming. He says that you have to consume 3 times a day. Okay, so you take first dose. After taking first dose, you get certain relief. After taking second dose, you get still more relief. And after third dose, what many times happens that you become quite normal. No doubt your health is not up to the mark, but you are quite normal. Now the next day the problem starts. The doctor has asked you that you take this particular course for 5 days. So what you do, you start consuming next day morning the same tablets. These tablets are not having any work to do when they enter in your stomach, because whatever was required is already settled down. So now it starts finding out the substrate where it should start acting. So what happens? Generally, it is our common experience that when you consume this particular material, these medicines, in the next or second day or third day, you start getting acidity. Okay. So doctor has already taken care of that. He provide antacid for that, and he asks you to take antacid either in the liquid form or in the solid form. Now you go on consuming that. So meanwhile, whatever is this particular extra medicine, that extra medicine start working on your organs, and they generate lot of reactions, allergies, or they start generating certain another diseases. And so what happens that after say 5 days of consumption of all these things, you find that okay, you are out of fever, but you are having a very, very bad weakness, and you don't feel that you don't you are not in a position to stand up. You feel that I should sit, I should sleep, and so on. Now what are they? We call these as the reactions. Now these reactions are generated due to what condition? It is just because a drug has not reached to a proper position in a proper amount in a proper time, and that was the main cause, because it was administered in your digestive system. Very few part of that has reached to a affected organ, while the rest of the material is just lying here and there. It is working on other organs, and you start getting the acidity. This is a very common observation. Everybody of us has gone through this. So what is that? Now here the target is a targeted drug delivery system. So we'll come to that particular part later on. So this is the requirement of smart materials. So please remember, this is the requirement from the medical side, which we are understanding, and we are developing the materials which will concentrate on the targeted delivery of a drug at a required position. Now, because of this particular problem, what happens? Lot many allergies and lot many reactions are taking place, and as our total health system nowadays is very poor, so you start finding still complication and other diseases start appearing from this. So that's why these smart materials are required and their functions are required as the required position. Okay. Now the same title, smart material. Now I'm starting from the function. The function is actuator. I have just listed the 5 different stages of a disease, out of which the actuator definition, it moves in response to an external stimuli. Smart material example is shape memory alloy, and example of the current application is arterial stents. Now these are the stents which are put in the arteries directly. So these are the actuator. The function is actuating. The next function is color changing. Changes color. Now here you will find other applications also. Changes color in response to an external stimuli. It is photochromatic material, photochromic material. Now this is a very common thing, that is the sunglasses. Sunglasses that changes color with the direct sunlight. Now everybody of us is using this particular color changing function. Then self-healing, a material that can repair itself without human influence. Now self-healing paints are also available. Now one famous patented invention of Kawasaki vehicles. Kawasaki motorcycles repairing certain types of paintwork scratches. If there is a scratch on Kawasaki motorcycle, now this is not available in India, but you will find that certain Kawasaki vehicles. Now if there is a scratch, you will find that after 1 or 2 days, the scratch, it will itself get eliminated. That means you need not go for repainting or cleaning that particular part. So it will get removed on its own. Then temperature responsive, material that adapt the changes in temperature. Thermochromic thermometers identifies whether a specific part of a machine is too hot or touch. Now this is available nowadays in all cars. You find that on the dashboard, there are different panels, out of which one particular panel giving you the temperature. Now this temperature, if it goes beyond a certain point of level, you will find that some additional system work. That means if there is a cooling through the engine, then or the radiator, you will find that if it is excessive, immediately the blower starts and the blower cools that particular engine to a required position. So these are the temperature sensitive or the responsive materials. Then lastly, magneto-rheological fluids changes viscosity with the application or removal of magnetic field. MR, magneto-rheological fluids, reinforcing Kevlar armor. Now generally the Indian Army uses this Kevlar for armor plates. Now these armor plates are so typical that if there is irregular working, now the Kevlar material is a normal material, and if you find that the enemy starts bombarding on that particular material and you require that plate more harder, then that whole of the system is provided with magnetic field, and you find that this Kevlar material become more and more harder. Now this is a very typical type of observation. Now Kevlar is one part which is generally used in our helmets also. A helmet is generally made up of Kevlar. So this is a very typical example, smart materials. Okay, now we'll go with the areas of medical applications for smart materials. Shape memory alloys used in stents that can expand to open blocked blood vessels when heated by a small current. Then hydrogels can be designed to swell or shrink in response to our pH changes, enabling controlled drug delivery at specific sites within the body. Then piezoelectric material generate electrical signal when mechanical pressure is applied, used in sensors for monitoring physiological parameters like blood pressure or muscle activity. Then magnetostrictive materials respond to magnetic field, allowing for remote manipulation of implants or targeted drug delivery. Now this is a very typical application. Now potential applications of smart materials in medicine: drug delivery system, precise delivery of drugs to a specific location within the body based on environmental cues; tissue engineering, creating scaffolds with tailored properties to promote cell growth and regeneration for tissue repair. If you remember, I have given this as a case study in my previous lecture. Then implantable sensors, monitoring physiological parameters in real time with implantable devices. Then wound dressings, smart dressing that can adapt to changing wound conditions and promote healing. Now, all of us in our school days or in our college days have undergone a lot of wounds while playing, and it is a very troublesome part that after 1 or 2 days, the doctor asks you to replace the bandage. At that time, the removal of the bandage is so much painful that generally we avoid, or in our school days we try to avoid the doctor, and healing, let the wound heal on its own. So we never give this information to our parents also. Now these wound dressings, nowadays these wound dressings are very much smart. Now they can adapt the changing wound condition and promote healing. So it is supported with the medicine. Now this is a very typical example, and it is the highest version now we are having, while the lowest version which was there with our common example as the band-aid. Band-aid was the aid, or that was a sticking material which was supplied with medicine. In the older days, we used to put medicine on the wood, then put a cotton, then put a bandage cloth, and then start winding it with the help of bandage cloth. But nowadays you will find that there is a bandage. The bandage contains a small piece which contains the medicine itself, and you just put it, and generally it is observed that after getting the wound clear or condition, healing is completed, the bandage can be removed without any problem. Now this is the original or primitive part of our wound dressing. Then last is the surgical robotics, developing robotic tools with adaptable functionalities for minimal invasive procedures. That means these are the surgery part. Okay. Now I am repeating this particular part typically because in the previous one, the aspect was slightly different. Now I am trying to explain the same thing with another aspect. That means why all these things are required, that can be explained in short with the help of these particular types of smart material. Piezoelectric materials convert electrical energy to mechanical energy and vice versa. They offer a wide range of utility and can be used as actuators, that is, provide a voltage to create motion. sensors such as many accelerometers and energy harvester, since the charge generated from the motion can be harvested and stored. Common applications for piezo materials are BBQ igniters. Now, BBQ means these are the barbecue igniters which are generally used in restaurants, and actuators for inkjet printer heads. Now, this is our common observation. Inkjet printer head is having a piezoelectric transducer. Commercialization of energy harvester, haptic actuators. Now, these haptic actuators are a very typical one. It is a electronic device that stimulates the skin to create sense of touch. Now, this is a very, very advanced part. That is, it's an electronic device. It is related, or it is in touch with the skin, and that tells you about the touch. Now, what happens that many times the burned patient or the patient who have lost the senses, now for them, each and every time, you cannot go and touch, you cannot ask him continuously. But these haptic actuators are the actuators which senses that a human body after burn condition has reached to a normal position. Then that skin sensor or the actuator start giving the signal, and the doctor comes. Now for this, unfortunately, it may take say 3 months, 6 months, 9 months, and so on. So these are very typical type of what you can say, the devices which are used typically in case of burn patient. Now, piezo wall actuators, the flow control devices already done. Now, shape memory alloys, the most commonly available shape memory alloys are nitinol. Now, what is this nitinol? Which was originally developed by the Naval Ordnance Laboratory. That's why it is called as nitinol. And shape memory alloys have the ability to change the phase as a function of temperature, and in the process generate a force or motion. They are capable of relatively high energy but move slowly. Typical applications include morphing structures. Morphing structures are the structure where there is a change in the shape. Now, morphing structures are change in the shape. Now, shape changing devices, if there is a shape changing, generally shape memory alloys is required. Then thermal triggers and some high strain energy absorbing application. Then magnetostrictive materials, similar to piezoelectric materials that respond to change in electric field. This class of material responds to change in the magnetic fields and can perform as an actuator or sensor if deformed. Well, they can work well. They exhibit large hysteresis, which must be compensated when using the material in sensor application. Now, generally, the magnetism create lot many problem in electrical or electronic devices. So we have to use these systems typically with certain limitations. Okay. Shape memory polymers. Now, this is slightly different than the alloys. Now, these are the polymers. These are SMP, are similar to shape memory alloys, except the obvious fact that they are made from polymer matrix. They possess much greater recoverable strength than the alloys, but typically under lower forces. Morphing structure has been area of greatest use to date for SMP. So polymers. Now, generally, the polymers which are fit into human body as the implants, which are promoting the growth of the bone tissue. Now, they are supplied with this SMP. Okay, hydrogel, the most important one in the next category, because everybody of us is acquainted with this. Hydrogels can be tailored to absorb and hold water or other liquid under certain environmental conditions. Hydrogels have been around for a longer time, specifically in disposable diapers. Now, this everybody of us is knowing that the infants and the elderly people both requires disposable diapers. Now, these diapers are manufactured by hydrogels. Now, this is a very typical material which absorb a lot of things, and they are very much hygienic for a certain period of time. A key feature, however, is the gels can be tailored chemically to respond to different stimuli. It is possible to embed the gel into a foam, which enables system to be built with the gels, such as hydrogel activated bulkhead shaft seals. Now, in many of the war machines, now you require certain packings, you require certain seals. Now, these shaft seals are extremely difficult to fit because the shape is extremely critical, and beyond the capacity of metallic manufacturing. Now, as we know that the seals are bendable or they are elastic. Now, if you use hydrogels, now this particular solution can be easily found out. Now, electroactive polymers, there are many forms of electroactive polymers and many are still being refined. They have great potential as a flexibility of how they can be used, provide advantages over some of the metals and ceramic mentioned above. Most typically applications include energy harvesting and sensing. Now, these are just like our batteries. Now, these polymers, they harvest energy. That means you can store energy in these particular materials. So electroactive polymers will be the future. Now see, you must have heard that the Sony and the Samsung Electronics have already started designing the batteries, which the cell which are flexible. Means what? The cell which now we are having a button cell in our mobile. Now instead of a button cell, you will find that this will be a flexible polymer which will start generating or it will start accepting sun radiations and generating, say for example, electricity for us. Now these are not ahead that because of the electroactive polymers, our mobile phones will lose its identity as a hard phone. That means these hard phones will be converted into the soft matrix phones, which you can just fold just like your handkerchief and put it in your pocket. Now this will be within 2 or 3 years, you will find these particular types of phones, which are flexible phones, which will be obtained from Sony and Samsung. Okay. Now, biocomponent fibers, adaptive thermal insulation can enable smart clothing that can change its thermal properties based on the environment. Nowadays, this is having a very, very important aspect. Now, already in the market, you will find that there are certain clothings which, when they are exposed to certain temperature, they become a raincoat. That means your shirt or a t-shirt, after a certain period of time, if it is exposed to certain stimuli, it becomes a raincoat. That means it becomes water repellent. Similarly, now your t-shirt or a shirt, if it is coated with component fibers, in the winter season, the same shirt will be working like a sweater. So these are the days ahead where we will get these particular material coatings along with the fibers or an external coating. Lot of development in bicomponent fiber technology where two different materials are co-extruded together to enable shape change depending on the ambient temperature. Now these are the advancement in the materials. That's what the title is, advanced materials. Okay. Now I'm starting with the next part of our lecture. Now we are taking each and every material. I'm giving you certain names of these particular materials and we'll try to observe what are the medical applications, because now hereafter I am targeting specifically on the medical application. Okay. Now piezoelectric is a class of material that could generate an electrical output on the application of strain or stress. Piezoelectric energy harvester, PEH, are capable of harvesting various types of mechanical energy into electricity, unlike several other technologies such as triboelectric and electromagnetic. The wide variety of piezoelectric biomaterials and numerous devices designed could directly boost performance and make them compatible with the various operational environments. Motions from human movement and vital organs could be an effective medium for transforming mechanical vibration into electrical energy through pH. Now say these are the things which we are going to observe within 5 or 10 years. That means when you start walking, now you start generating energy. A mechanical energy which is generated because of your walking will be converted into electrical energy again. So see the cycle. You consume food, you digest food, you convert it into a energy, mechanical energy, supply it to your body organs. You start walking and that walking start again converting it into electrical energy. Means what? You will be your own generator. So these are the things which are coming to our life within 5 years, that will be our own electricity generator. Whatever is the need for our medical gadgets will be supplied by our walking only. Nowadays, you must have seen that in gyms, whenever you run on that particular stress track or say certain belts, it starts generating electrical energy. A simple BLDC motor can give you all these conversion. But nowadays, hereafter, you will find that small generators will be available with this very small shape material. That means you may not be seeing anything on your body, but you are a electricity generator. So this is the future. Within 5 or 10 years, this will be the condition. So these materials are extremely important for us. Now, these are the names of certain piezoelectric materials which we use in our system. Then polyvinylidene fluoride, PVDF. Then polyvinylidene fluoride, trifluoroethylene, PVDF, TRFE. Then poly-L-lactic acid, PLLA. Then collagen, chitin, then cellulose, bone, natural piezoelectric material, and certain proteins like keratin and silk fibro. Now, all these materials, they fall under this piezoelectric material, but these are specifically for medical application. That's why I'm listing all these things under the title medical application. Now, what are the applications or what are the units or the devices in medical sciences which can utilize these materials? Is ultrasound transducer, piezoelectric ceramics like lead, zirconate, titanate, PZT are commonly used in medical ultrasound imaging due to their high piezoelectric coefficient. And pressure sensor, piezoelectric materials can be used to monitor pressure within the body, like in the bladder or eye. Now here, I can give you one example that if you go to a eye doctor for which, for say checking your eyes or say getting your lens correction or sight correction. Now many times you must have seen that there is one particular machine in front of which you stop and the person suddenly exposes a mist of certain medicine along with air on your retina. Now, whatever is the response of your retina to this flow of fluid is taken care and it is monitored, and then he gives you certain reading. And then that particular machine, which senses the response of your retina for sudden impact of air or sudden impact of certain fluid. Why this is required? Up to a certain limit, your retina can bear all these things. That means it is not degenerated. Beyond a certain limit, you will find that your retina may get attacked with the tissues or the system generated due to diabetes, and there are chances that you may develop, say, for example, cataract. Now, the pressure sensors are the points when you visit next time any this eye surgeon, you just try to find out what are these pressure sensors. You can sit on that particular machine and suddenly the person asks you to open your eye and this particular system works. Now, these are pressure sensors. Then tissue engineered scaffolds, incorporating piezoelectric materials into scaffolds can stimulate cell growth and differentiation by mimicking the mechanical cues present in the national tissues. Now, last time, again, I have already given you this particular case study in tissue engineering. Okay. Now here, the same part which I have explained is shown here in a form of a picture. So you can just go through this particular picture. That's cell stimulation, then tissue regeneration, then human body energy harvesting. So these will be the equipments fitted to your legs, and this will start generating electricity. So these are piezoelectric materials in future. This is the content of piezoelectric material. The same is there. I'll not read all these things. I'll come to the right hand side, which are the application. Pacemaker, which is fitted in our heart. Pacemaker, then activity monitor, hearing aids, speech intensification, occupancy seat sensor, compartment switches, horn, then tire rotation scanning systems, musical instrument pickup, then drum triggers, toys, keypad, digitizers, mouse, joysticks, inkjet droplet generator. You'll find that everywhere in our day-to-day life, piezoelectric materials are there. So I have just collected this particular information for your information, for your knowledge, that lot of areas are there where piezoelectric materials are used. Okay. Now I'll come to the second point. Already we have studied this in greater detail, but some part will go into the minute part, typically for medical application. SMAs are materials that can recover their original shape after being deformed. They are used in biomedical application because of their biocompatibility, corrosion resistance, and mechanical property. Shape memory effect. SME is the property of SMA to recover the original shape after being heated. The SME can be used to create a useful shape in the material by heating it to a certain temperature, holding it for a period of time, and then quenching it in water or cooling it air. Now, this is the procedure of making that particular shape by applying time, certain coolant, and heat. Now, this is the students of metallurgy branch or materials engineering will be knowing all these things in very much great detail. Now, here I will just give you one particular example so that you can understand. Now, lot many times we observe and we hear angiography, angioplasty, and bypass surgery for heart. Now, generally, the angiography starts with inserting a small wire or a particular equipment which passes from your leg and it enters into your heart. And at that time, generally, the doctor observed that there are blockages in your heart. And there are certain things which are clogging, because of which you are getting certain problems. So what he suggests during that angiography, he immediately starts that if you agree, I will put a stent there. So immediately it becomes plasty, angioplasty. So at that time, what he does, now please remember our veins are very, very thin. Diameter is very less. So I cannot put a big material or a big unit or a big product when it enters to that particular vein. Then what should be happen? Now the stent is just like that wire. It enters into that particular one, and through that angioplasty system, some heat is provided or some mechanism is there, so that now that wire start coiling itself and it increases its diameter. So it becomes a coil like this. A wire itself get converted into a coil. When it is a coil, it enlarges the diameter of that particular vein. And if there is any blockage, some material clogged, it get removed or it is taken away from that. Now this system is available or it is done for so many years for angiography, angioplasty, and then bypass surgery. So the stent, I cannot make a coil and put inside in your vein. So it must be straight. It should penetrate from your leg and it should reach to your heart. And in that case, after reaching to that particular heart at a required position, then it should start forming its shape. So this journey of that wire is a straight wire, straight shape without having any coil. But when it reaches to that particular spot, it starts getting coiled itself. No external means are required. So it remembers its original shape. So I manufacture one particular coil. Then again, by heating, I have made it straight. Again, I put it into your body. And after a certain period of time, if I supply certain stimuli, heat or any PD, potential difference, then it starts coiling itself. And as a result of which, the vein size increases. It generally, we call it as a stent. That whatever is the blockage, that get removed or that is transported, blood supply starts, and the problem of that heart blockage or the vein supply of blood vessel to the required organs, that can be removed. Now this is the use of the material, that is shape memory effect is generally, which is shown here. We can just remember generally in mechanical engineering, we generally call this as some sort of this variety is called as the spring back effect, but that is not exactly, but it is also available there. So what are the materials? Nickel titanium, NiTi, also known as nitinol. This alloy is commonly used in medicine devices because of its biocompatibility, corrosion resistance, and osseointegration. So osseointegration means whenever they reach to a required point, generally the bones, now this is typically for bones, when the bone development starts, so tissue go on collecting on that particular material, then they hold that particular material from all the side and it becomes a unified bone. Now this is called, the process is called as osseointegration. Then the stents, SMA are used in stents to support or dilate blocked blood vessel. Just now I told you this. Surgical fixator, generally if you have unfortunately undergone any fracture, now there are two methods. Implants are kept inside, or otherwise generally it is called as the Elizarov technique, that from outside with the help of certain shapes, springs, nuts and bolts, now your bone is strained from outside by compulsion, and then tightening of this particular screw bring your bone, if it is broken, in position, if it is bent, again in position. Now these are called as surgical fixators. This is a very typical one. Then patellar concentrators is one particular part. Now these plates in knees, which is externally cured, the same part which is the surgical fixator. If it is in knee, it is called as patellar concentrator, are used in patellar concentrator to treat interpelvic infrastructure, just like our bandage, which we put as a temporary part if you are having certain pain in your legs. Now generally we put a bandage. Now that bandage provides certain relief to our movement, and as a result of which, as the load decreases, you start feeling better. Now these concentrators and fixators, they provide mechanical means. That's why these are slightly different. Orthodontic devices. Now these are the devices which are with reference to your teeth and your gums. Then orthopedic implants, that is, we already studied this SMA used in orthopedic implants, that is the bones and other things. Okay. Now shape memory alloys. Now the same part on the left hand side. What are shape memory alloys? If it is nickel titanium, that is nitinol, then silver cadmium, gold cadmium, then copper aluminum nickel, copper zinc aluminum nickel, and copper tin, copper zinc. These are the different materials which are used for manufacturing the components from shape memory alloy. Now this is a man on whom you can see on his body variety of locations are shown, and where we can use shape memory alloys or SMA. Generally we call them as implants. Orthodontic brackets. Now many times people, you must have seen that there are braces and brackets on their teeth. That means externally the teeth are brought in position. So the doctor produces that particular one. Now please remember that the teeth pattern, jaw pattern, gum pattern of each and every person is different. So you cannot standardize the brackets. Now these brackets are to be manufactured. That means it is a tailor manufacturing. Now the second point comes that if the tailor manufacturing comes, then it gives you the shape of your teeth, but it do not create any pressure. So if you are having shape memory alloy, the shape of your teeth, top or the bottom, will be generated mechanically, and then shape memory alloy will do its further work. That means it will just come to its original shape and it will exert a pressure so that the teeth which are not in correct line or the position, that is having an external pressure, and after a certain period of time you will find that it get aligned with your teeth. Now these are the orthodontic brackets. Shape memory alloys are extremely useful for changing the shape of this particular one. These are called as the braces and brackets. Dental implants, then spinal cages, then leg screws, then knee implants, then heart valves, then coronary stents, then hip implant, then trauma nails. These are the just like our normal nails. We are having these particular nails in our system. Okay. Next, so we'll go to the next part. Next group of material is the magnetostrictive materials. These materials change shape when exposed to magnetic field, have potential applications in the biomedical field due to their ability to generate controlled mechanical deformation. Now see, this is a very important word, controlled mechanical deformation. These are suitable for applications like remote actuation of cells, targeted drug delivery, and stimulation of tissues regeneration, particularly in bone repair, by applying external magnetic fields to trigger precise mechanical stress on the targeted area. Now you can just visualize one particular type of a condition which I am trying to put in front of you. Now suppose there is some accidents and your neck is deformed and you find that your neck is not in position. That means your head is not erect and you just have a certain angle, tilt angle. Now here it is so much difficult to have a mechanical pressure. Say the occupational, what you can say, the people who are having this particular trouble. Generally, the people who are carrying load on their shoulder or on their head, now they undergo this particular type of deformity. So your spinal cord get deformed slightly. It is very difficult for an older age person to give him certain exercise and make that particular one straight. So what is done, that these particular materials are put in that particular operation underneath, and then externally magnetic field is applied, so that particular small part slightly gets straightened. Then according to the requirement of a patient, the pains which he can bear up to that particular one, it is go on changing until that magnetic field is applied, that material changes its shape. Once you stop that magnetic field application, the material remains at that particular position. Now this is loading internally and not externally. Now these are the magnetostrictive materials which are used in orthopedic surgery on a very large scale. Now what are these particular functions? Actuation and sensing. Just I have explained this. The primary benefit of magnetostrictive material is their ability to act as a both actuator, that is generating movement, and sensor, that is detecting changes in the magnetic field, making them useful for developing implantable devices that can respond to stimuli and provide feedback. Targeted drug delivery. By attaching drugs to magnetostrictive particles, researchers can precisely control the delivery location within the body using an external magnetic field. Then third one, tissue engineering. Magnetostrictive materials can be used to stimulate cell growth and differentiation by applying controlled mechanical stresses to cell, potentially aiding in tissue generation and especially in bone repair. So this is a typical tissue generation in engineering, tissue engineering work. And lastly, biocompatibility concern. Now this is the sensing. Whether a particular implant is accepted by your body or not. Now that is a very $1 million question, because putting an implant is comparatively simple than accepting it by your body. It is very, very difficult. So biocompatibility testing is a very big area nowadays, because an average Indian person, around 60% of people are having certain implant in their body, and these implants are having a finite life. Now the person has to check his compatibility with the help of external part, because now the implant cannot be removed, the implant cannot be tested, you cannot put anything else, otherwise it will be another surgery. So externally checking this biocompatibility is very important concern. It starts with your titanium alloy, which is put as a screw in your dental implant. Whether that particular screw is having biocompatibility or it has generated certain problems, certain organisms have developed, certain viruses are there, it is generating certain problem, there are pains, or it is generating certain unwanted fluid or pus. Now that is biocompatibility concern. So these magnetostrictive materials can give you this lot of feedback. So these materials are very much important afterwards, once that particular implant is fitted in your body. Okay. Now the magnetostrictive materials, we are having typical application. Now this particular diagram gives you a lot of information. Now what are these two materials? One particular material is terphenol. Now this terphenol is then alloy. Now it contains terbium, then dysprosium and iron in it. Now this is a very typical material. Actually these are the patented materials which are magnetostrictive. Now these materials, a commonly studied magnetostrictive material with high magnetostrictive strain, often explored for applications like bone regeneration. Then galphenol is another alloy. Again, this is a patented material which is iron and gallium alloy. Another promising magnetostrictive material due to its relatively high strain and good biocompatibility is galphenol. Now what is this particular diagram gives you? Now the diagram is, now it gives you a lot of information, like on the left hand side, construction strategy Then the middle portion is application, and right time is the prospect. Okay. So magnetic field induced arrangement, if you go for MNPs, that is these MNPs are generally, I'm sorry, these nanoparticles. These are nanoparticles. So MNP in matrix, MNP is only or it is in matrix. Then orderly manufacturing based construction, order to order to magnetism and magnetism to order. This is the reverse one, which we can have. This is the construction strategy for that particular material. What are the applications? Now the applications are different. It may be cell research or sulfate research, then bio-inspired fabrication. Then you are having the third one as the magnetostrictive. MNP is magnetostrictive nanoparticles. So we are having this particular 4 or 5 parts which are there: bio-inspired fabrication, sulfate research, magnetically ordered materials. Now this is MRI, magnetic resonance imaging, and this is magnetic hypercephalmia. Now this particular are the systems which are the cultures. Now these cultures are developed and they are subjected to the magnetic forces. So these forces magnetically order materials. In short, we have studied the materials, or we have developed biological materials. We have developed, say for example, metallurgical materials. We have developed, say for example, electrical materials. Now these materials are magnetically ordered materials, means they act only when a magnetic field is applied on it. So what are the prospect? Interdisciplinary research, safety, and functional and structural diversity. Means what? Only thing is that when you have these particular materials inside your body, and if the test results which are obtained with the help of, say for example, sonography, X-ray, MRI, or any such particular type of testing machine, that should not get hampered. So you must have seen that steel materials, whenever you go for X-ray, the X-ray technician will ask you to keep coins away from your body. Then your watch, if it is metallic watch, away from your body. That if your spectacles are having metallic ring, metallic frame, he will ask you, because these material absorb X-rays. Now, and it may mislead the result. That's why the magnetostrictive materials and applications require this consideration, because majority times these particular testing methods uses magnetic field. So it may crisscross with your material implant, and it may generate certain invalid diagnosis. So that's why you have to consider all these factors, magnetically ordered material. So though they are independently good things, but for testing, many times magnetostrictive materials create certain problems. So that is the part which is important to be noted here. Now this is the big part which is shown here. So for MNP, that is magnetostrictive nanoparticles. Now this is generally with reference to nanoparticles. Okay, so I'll try to explain all these things. Now you can see there is a big circle and there are 4 different headings: health monitoring, then virtual reality, then tactile sensing, and location and navigation. So these are the group of sensors and devices which can give the information in different formats in these particular areas. Okay, so these are the areas where you can have information with the help of this sensor. So I'll just read one by one. Now these are different sensors. GMI sensor is giant magneto impedance sensor. TMR sensor is tunnel magnetorestrictive sensor. Then GMR is here. GMR is giant magneto resistance sensor. Then AMR sensor. Now this is anisotropic magneto-resistance sensor. Then there is a Hall pitch sensor or a Hall sensor. Majority of you might be knowing this. And there is a ME sensor, which is magneto-electric sensor. Now, please remember that this is the field of electronics, where we are sensing the things which is required for the drug sensing, identification, selection of a drug, then delivery of a drug, and finally checking the results. So all these particular systems require certain sensing devices. Now these devices we can manufacture from these magnetostrictive materials like GMI sensor, TMI, and so on. Now how these sensing devices are fitted or replaced by these particular materials. So please remember, this is a very important aspect. They are fitted or they are directly replaced. For example, magnetic fiber, then magnetic ink, and magnetic thin film. These are the replacement with these particular sensors. Now you can have these particular sensing devices incorporated instead of a hard electromechanical, electro-opto, or any electro sensing device. Instead of that, you can use this particular material. Now these materials, majority of these particular materials are digestible by human body. So they perform their duty and get digested in the system. So in the next drug delivery system, I will try to explain that particular part. So this is astonishingly reducing the requirement of hard components which are technically required in all these sensors. Now these sensors, majority of the sensors are having big electronic systems. It requires certain, say for example, if you take a simple resistor, after certain time of use, the resistors start getting heated. It start generating heat, and it's what you can say, the performance reduces. So these sensors, they don't generate heat at all. On the contrary, they will create heat if you require. So as per our requirement, we can go on utilizing these particular materials. Okay. So here you can see the application. This is for magnetic particle. This is for a typical, what you can say, this CMR generator. Then a person who is walking or running, for him you can have the sense. Virtual reality, these sensors can generate the reality. That means you can have the feel of being there at a distance, from a distance. So that is required whenever the inside part of human body, which is not visible. So for them, you must have, the surgeon or the doctor require virtual reality. Then there are tactile sensing. These tactile sensing, a simple example is given. There is a small ant which is walking on your body, and it is having a small walking distance, and also it is trying to bite you. Now that particular sense is having the tactile sensing. Now this tactile sensing, a small insect bite can be sensed with the help of this particular material. So they are very important. Then location and navigation. So location and navigation. Nowadays you must have seen that in our mobile we are having a lot of location and navigation devices. Also we are having cameras which are real-time cameras where you cannot cheat people. So all these details, you can have these particular types of sensor. Now this is the environment. Now this is the hardware which is required, and these are the replacements. So we are coming to the center of this particular circle with the help of this advanced material with very small size. Even many times it is on the nano size. Instead of getting information from say for example from ultrasonic imaging, you can put a pill in your mouth which is having the infrared camera. That camera, as the pill passes from your mouth to the intestine, it go on tracking your part with the help of a small light. It will enlighten all these things, and that particular signal is on your screen, and you physically find what is going on inside, and starting from entry of that particular pill or capsule in your mouth to the required position, you can have that particular sensing. So the location, navigation, real-time monitoring is nowadays possible with the help of these smart materials. Okay. Now I'll come to the next part, that is pH sensitive material. pH sensitive materials refer to the substances that change their properties based on the acidity or alkalinity. Now, if you just understand this information, you'll find that pH sensitive materials are extremely useful and a lot of applications in our body, because our body pH is acidic or alkaline depending upon what you eat. So this is a very typical observation. So we generally call that I'm having acidity. Means what? Your bile composition is changing, amount is changing, it is in excess. So immediately you start feeling certain stimuli or certain signs from that particular acidity. So alkalinity, pH level of their environment, allowing for targeted drug delivery to specific areas of the body with different pH levels, like the stomach, that is acidic, or tumor microenvironment, slightly acidic, by releasing the drug only when exposed to the desired pH conditions. Common example include polymers like chitosan, hyaluronic acid, then alginate, and polyacrylic acid, which are often used in create hydrogels for controlled drug release. Now here you have to just understand the mechanism. Now see, antacid is a common part, and we are having a lot of antacids in our house. You must have seen that one capsule is a transparent capsule, and in which there are small granules, which again they are coated with transparent small spheres. Now sphere containing inside which there is a medicine. Now see, when you take this particular pill, now generally the upper capsule, it get digested, or it punctured in your intestine. At that point, certain drugs get released and it starts working. As that particular progresses further, then that goes to your intestine. At that point, certain drugs get released. It starts working. And finally, it reaches to the colon. And then at that point, certain drugs get released. Now, these three positions, drugs get released. This is quick, but the action of all these things to get converted or to get attacked with that particular disease requires 3 to 4 hours. Why this is so? Because our drugs are in the macro scale, and that macro scale require digestion. And when it get digested, then the drug starts acting on the diseased area. But if you go with the nanoparticles, you will find that this particular system will work because the nanoparticles are small, so small in the size that whenever they reach to that particular position, immediately they get absorbed without going into the digestion cycle of your body. So naturally, this particular system is more efficient, and you'll find that it can cure your diseases within a short time compared to the traditional drugs. Now, last time I already mentioned that in our Ayurveda, the bhasmas or the churnas were nanoparticles, or even in nowadays homeopathy, you'll find that the titrations, that is 1x, 2x, 10x, 100x, these are the nano scale medicines, and they act very quickly. If proper diagnosis is done, you will find that they get absorbed in your body so quickly that within short span of time you can cure from your disease. Now this is the very typical cycle, and these pH sensitive materials are used in our system on a very large scale. So the mechanism I have already mentioned: targeted drug delivery, wound dressing, then gene therapy. And what are these materials? These are natural polymer chitosan, then hyaluronic acid, then alginate, then synthetic polymer, that is polyacrylic acid, polyethylene amide, then DNA, then polyvinyl alcohol. Now these are acting on these particular required places where the working principle is the pH. Means the drug will get released from the capsule only when the targeted pH is there. Means what? If your bile is in excess coming from your liver, and if the acidity is there in your stomach, then and then only that pill will open, otherwise not. So it will pass through your stool later on. Now this is the working of the pH sensitive material. Means what? It is acting only when there is a sensitivity of pH level. So less than 6 or up to 6, it will be acidic. 7 is neutral. More than 7, it is an alkaline. So these are the pH sensitive materials which are used in our body. Now whatever was the part which I have explained in the previous one, now that is shown in the form of a case. So drug loaded hydrogel is taken in your mouth. Now this is your digestion system. Swollen cationic hydrogel, if it is cationic, then drug release in the stomach. So in the stomach here the drug get released. Now see, this is very important point. So at this point, if it is required to get released in stomach, it will release. Otherwise, normally what happens that instead of going here, the whole of the drug passes through this particular system continuously. This will get released only here, neither in your mouth or in your digestive tract but it will get released here. The second part is swollen anionic hydrogel, drug release in the intestine. So it will get released only in your intestine. So it will pass through this particular system without getting affected. When it comes here, then it will start releasing. Normally what happens, normal drugs, they get released or they get exposed to your whole of the digestive system, and here it doesn't have any work. So it will start working on your colon. It will start working on your stomach. And as a result of which it will get damaged, you getting certain reaction, you will start getting certain allergy. So in the second point, it will get released only in the intestine. And the third one, microbially degraded hydrogel, that will start from here, it will not get released, it will pass through your whole of the system, and finally when it enters into your colon or the large intestine, it will start working. So people having the problems of colon, for them this is the part. Otherwise this has to go through the metabolic activity or the metabolic digestion, and very small part of that drug reaches here, and that's why the treatment get prolonged. So that is the major problem. Now these smart materials will take care of all these things. Okay. Now this is the last slide, which I will conclude here. pH sensitive hydrogel in drug delivery. Now actually I'll just explain this particular part. Whatever we have considered just now, actually this is a biological system. Now in this biological system, this work. Now we are having the system where natural, polyanion and polycation, these are the mechanisms. For which, what are the drug carriers? Will be MSM, hydrogels, then polymerosomes, then polymeric micelles, then dendrimers, last time we have already considered, then liposomes, nanoparticle. Now these are the carriers. That means this will contain the drug. Then they will start working. I have already explained right now. So there is no need this particular part. So this is specifically for cancer. So types of pH sensitive drug delivery system. These are the nanocarriers. These are the tumor targeting via pH sensitive drug delivery system, and mechanism of pH sensitive DDS. So this is specifically for cancer. Now, if the time permit, I'll just try to show you one small video which will try to explain all these things. Now, just give me some time, and please give me the feedback whether you can see this.
Yes, sir, you can run the video. The YouTube window is there now.
Sorry.
So voice is not coming from the video.
Patil sir, may I audible?
Yes, sir.
Yes,
Yes.
is it audible?
Okay.
Sir, voice of the video is not audible. You are audible.
Okay, okay, just a minute.
Sir, at the left side of the bottom, yes.
No problem. I could not find out what is happening. Sir, what is happening? Can you guide me?
Shekhar, sir.
Is it
Uh,
something with?
Yes, sir. Share the that video from share window screen, sir.
Okay, just a minute. Just I will close this. Yes, is it audible?
No, sir, it's not audible actually.
Shekhar, sir, can video be run separately coming out from PPT?
It's a YouTube video, sir.
Yes.
So while sharing, if you select window, and from there we need to select the YouTube.
YouTube
And under
window.
that, yes, yes.
Patil sir,
Sir.
uh, if you it is possible to download the YouTube video and then you can play.
Yes, yes.
Uh,
Sir, uh, may I try from my side?
Yes, yes,
Jeurkar, sir.
definitely, definitely. Yes, yes, definitely.
Nanoparticles for cancer treatment.
Yes, yes.
Three.
You can have that particular link on the last page. The link is there. You can copy that link and put it into YouTube. The
Sir,
last
can you?
slide.
Shekhar,
Sir,
sir,
yes, sir. Can
will
you
you try?
please paste that link into the chat box so that we can play from here, sir.
Okay, just a minute.
Shekhar, sir.
Yes, is it available?
Yes, sir. Yes, sir. Shekhar,
Yes, sir.
sir.
Yes,
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 Hi.
sir.
it
Please
is.
stop your screen, sir. Screen sharing.
Yes, yes, definitely.
Last but one, na sir.
लास्ट निफ्टी का 15 to 20 years का आप डेटा उठा के देख लो. निफ्टी हैज गिवन यू
Sir, is it audible, sir?
Yes.
Yes, sir, audible, audible.
Okay, okay.
Imagine that policemen are chasing terrorists and the terrorists enter a crowded area to hide. It would then be difficult for the police to target the terrorists, as the bullet has high chances of hitting common people instead of the intended ones. The same happens when doctors and researchers try to kill cancer cells in a human body. While drugs or radiations are administered to kill cancer cells, it also adversely impacts healthy cells and might even kill them. This is one of the major issues that makes it difficult to treat tumors or cancers without side effects. Luckily, researchers have found a solution to this problem in tiny particles or nanoparticles. These tiny particles are called nanoparticles because they are a few nanometers in size. And a nanometer is 1 billionth of a meter, or you can imagine them as 1 lakh times thinner than a strand of hair. The nanoparticles are 100 times smaller than the cells, and this small size allows them to easily be undertaken or absorbed by the cell. A nanomedicine made to treat cancer has nanoparticles with drugs inside. The nanoparticle has a cancer-specific ligand on its surface, and therefore it only attaches to cancer cells. Here you can imagine the nanoparticle as a postman who delivers packages at the given address. Once the nanomedicine attaches to cancerous cells, it is taken up by these cells. Once inside, these particles release toxic drugs inside the cancerous cells to kill them. All in all, nanoparticles act as drug delivery agents, ensuring that only the targeted or unhealthy cells receive drugs, leaving the healthy cells unaffected. Indian scientists have also demonstrated the use of nanoparticles in treating cancer. In a study published in the journal Bioconjugate Chemistry, they showed that gold lipid nanoparticles have a potential to be used as drug delivery agents. Interestingly, these nanoparticles can convert incident light into heat and increase the temperature of cancer cells, eventually killing them. Cancer is the second leading cause of death due to diseases worldwide, and nanotechnology raises our hopes to soon find a way to cure this deadly disease.
Okay.
Yes,
So with this, I will conclude my lecture. If anybody having any question, query, or any doubt, he can ask me. I will try to give the answer to my knowledge level best. This was, in short, the story of these advanced materials, typically the smart materials, applicable for the field of medical sciences. So apart from this, there are many fields where the smart materials are used. But as my topic was specifically reserved, the first lecture as well as the second lecture, which was in continuation with that. So I have chosen the topic of medical field because generally in our engineering courses, we never come across with these particular applications, and where the engineering and technology is required on a larger scale. So thank you very much for your cooperation. If anybody is having any question or query, I will try my level best to answer it.
Thank you, sir. Thank you, sir.
Can
Yeah.
unmute their mic and can directly ask the question. or you can type in chat box also.
Any participant? You can ask the question. So someone has raised a hand, you see.
Archana BS has raised.
Good evening, sir. Hello.
Hello.
Yes, sir.
Am I audible, sir?
Yes, you are audible.
Sir, the question regarding is metrological aspects of nanomaterials.
Metallurgical aspects.
Metrological.
Metrological aspect. Okay. Now see, as the manufacturing of nanomaterials is basically on the nanoscale. So metrology in a conventional sense is not applicable to nanomaterials, because when we say metrology, in metrology it is a science of measurement. Now the science of measurement for this is nanoscale.
So camera on करायचं असेल तर करू शकतो.
So here in this case, the metrology of nanomaterials will be the proper word. Technically speaking, it is the manufacturing on a very nanoscale or a micro scale. So conventional metrological things will not be applicable there because of two important reasons. Number one, on a nanoscale, the material changes their properties than compared to their parent. That means the solid material or a powder and the same material in nanoscale, you will find the properties differs drastically. So whatever is the logic for the material in its physical format is not applicable to the nanomaterials, as the property changes and everything change. So you can say that if you talk in terms of metrology, now that will be the metrology of nanoparticles. And for that, right now we do not have any specific such thing. During the manufacturing itself, the care is taken, because external checking, conventional checking is not possible.
Hello, sir. But regarding confirmation of proof of or just our products is manufactured with correct scale, or how to confirm it?
No, during manufacturing you can confirm. Generally, all nanoscale systems, they are confirmed with the help of scanning and other electron microscope. You can confirm it, no problem. Microscopy is the solution.
Okay. Thank you, sir.
Yes.
Sir, can I ask these questions afterwards also?
Yes, no problem. No.
Okay. Thank you, sir.
Matin Sheikh sir, do you have any question? You have raised the hand. Matin Sheikh sir.
Yes, sir.
Yes.
Jeurkar, sir.
Yes, sir.
Good evening, sir.
Good evening.
Sir, my general question was that, sir, I am also having a research done regarding the polymers for the controlled drug release one.
Okay.
So there are a lot of research has been carried out that in the case of the controlled drug release one.
Correct.
Right, but in the market we cannot see the products till now, sir. What may be the reason behind this one?
No, market, there are products, but see, in the last lecture I have mentioned that particular one. See, the question is that during these targeted drug delivery systems, the manufacturing of the medicine, manufacturing of the carrier, they are so costly that a normal person cannot afford all these things, unless otherwise it is on a very large scale manufacturing. I'll give you just one particular example. Unfortunately, if somebody got a heart attack and he is admitted to the hospital, immediately the doctors give you the packages. That means if this particular type of stent is kept, you will have to pay 1.5 lakhs. If this is the condition, you have to pay 5 lakhs. If this German make stent is used, it is 7 lakh or like that. Now, for such particular high packages now majority times these controlled delivery or targeted drug delivery systems are used, unless otherwise you pay for it. In normal market, you will not get these particular things. This is on a very heavy charge scale. Till date, the conventional pharmaceutical drug manufacturer are superseding these nano drugs, or you can say these targeted drug delivery system, because you have to pay for it, and a normal man cannot pay all these things. He will say, okay, whatever may happen, I will just consume the conventional. Because if you go to either general practitioner, you must have seen like this, that people will, if he says that you have to take these drugs for 3 days, the person always purchase the doses for 1 day, and if
Yes.
he feel better, then immediately it drops down the next 2 days. Now, because the cost part is very important for us, because the healthcare systems are so costly, normal people cannot afford for that. Very costly systems are there. So at higher packages, wherever there are, when you are paying very heavily, naturally these particular drugs are available for that, because they are manufactured on a limited scale and they are very costly.
Okay, sir. Okay.
Archana BS madam. Archana BS madam, you have raised the hand. Have you any question?
I think she might have wrongly raised a hand by mistake, maybe. Okay, anyone more? Anyone else have the question? Otherwise, we will wind up this session. So once again, very informative session by Jeurkar sir. His vast experience in the field of material science, biomedical materials, in 2 sessions we have experienced. So definitely the freshers in the research field and those who are doing research in the material field, definitely they will get the benefit of this. So on the behalf of AICTE Atal and Sri Siddheshwar Women's College of Engineering, our principal, organizing committee, thank you very much, sir,
Thanks.
for your time and delivery of such a excellent session. So I thank you once again, and I will share the PPT what you have given to the participant, which will help them in the online test. So thank you once again, sir.
Thank you.
And all participants, the feedback form is given in the chat box of this session. So all should fill the feedback, and the next resource person is there just now, Dr. Anil Ghanwat. So I welcome Dr. Anil Ghanwat also. And I thank Jeurkar sir once again.
Thank you, sir.
Yes, sir. Thank you.